that if he takes the number of terms he needs, and remember, how did he get 101? When he took the first plus the last, and then he divided by 2, you know, that would be the same thing as the number of just one of these series. And so this is what we come up with. Let's take a look at what he has. We wanted 100 terms. We found that the sum of each of those was 100 plus 1, and then we needed half of them. So we can use, if we're given a summation of that nature, we can then just use the abbreviation or the pattern that we see of multiplying the number of terms by the number plus 1 divided by 2. Well, these summations also have a shortcut, and they are also dependent upon how many terms. So we take, if we have I squared, we're going to take how many terms we have, multiply to that 100, the number of terms plus 1, and then 2 times the number of terms plus 1 divided by 6. Why does it work? Because if we look at lots of examples and we do some algebra on it, it actually does turn out to be this. And this is the same way with if summing up the cube of a value. So we're going to, instead of trying to prove that these work, we're going to just use them. Again, the summation of a constant is the constant times the number of terms. Okay, what we are going to be doing then, I'm actually going to show you this entire section, but we are going to, I'm not going to hold you responsible for all of the mathematics. Now, those of you going into Math 70, you will need to understand more of what we're talking about here. So pay special attention to this and maybe even listen to it a couple of times. Okay, so on this problem, we're asked to use sigma notation to write the sum. So we know we're going to write the summation of I ranging from 1 to some value up here. We don't know, we can't tell from here maybe how many terms, but let's analyze this. What is the same and what is different in each of these terms? Well, each of the terms have a 5 in the numerator, okay. Each of them in the denominator have 1 plus a quantity. So if I look at what changes, I have denominator 1 plus 1, 1 plus 2, 1 plus 3. What would be the next one? Denominator 1 plus 4, all the way up to 1 plus 15. Now that gives us the hint, how many terms do we have? Okay, we have 15 terms. What is going to be the quantity that we are adding together? Well, obviously in each of these we have a numerator of 5, a denominator of 1 plus a value that is changing. How is it changing? It's going from 1 up to 15, so it would be 5 divided by 1 plus I. Okay, next problem. Evaluate this sum. Well, in this sum, we have 10 terms because we're going to go from 1 to 10. And we're going to, we have a couple ways we could do this. Let me show you one way. One way, the first way, would be to take the summation and say, well, that's equal to 1 squared minus 1 plus, the index changes to the next whole number, 2 squared minus 1 plus, I'm going to keep doing this until I have 10 terms here, 3 squared minus 1 plus 4 squared minus 1 plus 5 squared minus 1, and I'm going to now up to 10 squared minus 1. Now, if I'm going to add those up, I'm going to have to say, well, 1 squared is 0 is 1, 1 minus 1 is 0. 2 squared is 4, 4 minus 1 is 3. 3 squared is 9, 9 minus 1 is 8. 4 squared is 16, minus 1 is 15. 5 squared is 25, minus 1 is 24. 6 squared is 36, minus 1 is 35. 7 squared is 49, minus 1 is 48. 8 squared is 64, minus 1 is 63. 9 squared is 81, minus 1 is 80, and 10 squared is 100, minus 1 is 99. And so I would then add up all of those terms. Let's see if we can get another way, another method of doing this. Looking back at our properties back here, we have that if there is a summation of two terms, we can have the summation, the sum of the summation of the terms. So let's see if we can employ that here. We can have this to be the summation as I goes from 1 to 10 of I squared minus the summation as I goes from 1 to 10 of 1. Now again, those rules that we were looking at will help us, so you can go back in your notes to find those. But the rules that we're looking at would tell us that the summation of I squared is the same thing as we have 10 terms, and then we take the number of terms plus 1, multiply that with 2 times the number of terms plus 1, divide by 6, minus, and the summation of a constant is the constant times the number of terms. So this would be 10 times 11 times 21, divide by 6, minus 10. And either way that you want to compute that, we should come up with an answer of 375. And I'll let you verify that on your own. Now, we get into then the using of this in order to come up with the area of a plane region. We're going to, again, this is going to be based on the area of some rectangles. We know the area of rectangles base times height. They're either going to be inscribed, and when we say inscribed, that means that we're going to underestimate the area because we're going to be having them inscribed in this area here. So we're going to end up with some areas that are not covered, or we're going to have them be circumscribed, which means we're going to overestimate, and on that then we would have areas above that should not be added or counted, but they are. Okay, we're going to circumscribed in a curve over defined closed interval from A to B. Our example on the Inspire was from 0 to 2. We have that B is the summation, the difference of the inputs, and that H is going to be f of x. So the base of the triangle is going to be the difference between the input values along the horizontal axis. So if I'm going to go from 0 to 1 and I want 1, 2, 3, 4 rectangles, so if n is going to be 4 rectangles, then the change between each of these is going to determine the base of my rectangle, and that's going to be how much the input changes between each of these, or for each of these rectangles. The height is going to be determined by whatever we come up with, f of x, and so if we do a circumscribe, then we'll have a height of f of x according to the left endpoint of this first rectangle. So the first thing we need to do is determine how many rectangles. That's the first thing. The second thing to do is determine the width of each rectangle. We can do this by if I'm going to go from 0 to 1 and I want to have 4 rectangles, then my width of my rectangle, B, the base, or the width of each rectangle, is going to be 1 minus 0. And I see we're using b in another sense, so we won't use it there, but 1 minus 0 divided by 4, or each rectangle will be 1/4 of a unit wide. Now we're going to determine then the delta x, that is the width of each rectangle, for y equals 4e to the negative x using n equals 4 for this interval. So over the interval 0 to 2. So if we're going to determine for this function, we are going to have, again, delta x. And now we have an interval from 0 to 2, so it'd be 2 minus 0, and we want 4 rectangles. So each rectangle is going to have a width of 1/2. Okay, the next thing we need to do is to determine the left endpoint input value, and that is by taking, remember our interval back here, the interval is from A to B, so that would be taking the leftmost value of our interval plus the number of the rectangle number times the interval that we have. So for this function here, we have an interval of 0 to 2. So we are going, and we want n equals 4 rectangles again. So for I is equal to 1, to I is equal to 4, we would have that delta x, we just determined, was equal to 1/2. That was on the other one. So for the left endpoint, we would have 0, because that's the left endpoint of the value of our interval, 0 plus I minus 1 times 1/2. Now, let's look at this function. So I'm going to pull up a new document, and we'll look at a graph of this. And again, our function is 4 times e to the opposite of x value. And we're looking at an interval from 0 to 2. So we'll set a window of, let's say negative 0.25 to 2.25. And we'll scale by 1. And let's look first at negative 0.25 to, well, let's say 5, just to kind of get something going here. And we'll take a look at that. So we're going to go from 0 to 2, and we are looking at 4 rectangles going between 0 and 2. Now, one thing we could do, I'm going to go back and change the window setting. If I'm going to have 0 to 2, I want 4 rectangles. Each rectangle, we said, is 1/2 unit. And so I'm going to break this up so I can see the base of this. We're going to use the left endpoint for each of these to determine the height of our rectangle. If we, let's just do this. Go into menu, go to shapes, go to rectangle, and if we go from the origin over to 0.5 and come up so that the rectangle is on the curve. Now where the finger is pointing is off the curve, but what I'm looking at is over here on the curve, and press enter. And so I'm using the leftmost endpoint of this subinterval. What is the value of that? Well, let's see. For the first rectangle, we would have 0 plus 1 minus 1 times 1/2, or 0. is that in fact the coordinate of the leftmost endpoint? And in fact,